Hi, Joe. Welcome to the podcast.
Hello, thanks for having me.
Let's begin with a brief intro to yourself.
Yeah, my name is Joe. I've been working in computer vision and sort of learning research for, I don't know, since about 2013 when I started grad school, I guess. Um, I work now at the Allen Institute for Artificial Intelligence, AI2. I've been working recently on geospatial foundation models, which is why I'm here today.
Fantastic. For people that are not familiar with AI2, what's its general remit?
Yeah, Paul Allen started AI2. Paul Allen, one of the co-founders of Microsoft, started AI2, I think about 12 years ago. And he was interested basically in artificial intelligence for solving big real world problems. I think it's something like AI for the world's biggest challenges or something like that. So it's gone through a lot of different sort of phases over its existence. But these days it focuses a lot on um, open ecosystem stuff. So open language models, open vision models, sort of training things in the open so people can understand how these things are trained, what kind of data goes in, what kind of compute, that kind of stuff. It also has a number of AI for science initiatives. So working on AI for cancer research, AI for general scientific research, those sorts of things, paper discovery. And then I fall under kind of the AI for the environment, AI for climate push that AI2 is doing. So as part of that, there are a number of different projects that AI2 is working on, but there is the climate modeling team, which is just trying to do sort of standard climate modeling stuff, but augmenting it using AI. There's projects like EarthRanger, tracking sort of endangered species, Skylight, looking for illegal, unregulated fishing, and then OlmoEarth.
hmm So that's probably a great time to learn a bit more about OlmoEarth.
Yeah, so OlmoeEarth actually came out of all of these other initiatives, basically things like EarthRanger and Skylight. AI2 had a bunch of partnerships already with these external organizations that were trying to solve various problems. And one of the things that people kept coming back to was this need for analyzing satellite data, geospatial data, and the lack of expertise in a lot of these uh, nonprofits and NGOs that we were working with in doing this kind of problem solving. So the OlmoeEarth project started about a year and a half ago. Some of the people who were working on Skylight actually, because Skylight also uses Sentinel-1 and Sentinel-2 data, some of the researchers who were working on Skylight decided it would be a good idea to build a more general purpose foundation model for geospatial images. They started the OlmoeEarth project. And since then, it's grown pretty fast. I think we have about 20 or 30 people working on the project as a whole, about 6 people working on the foundation model itself. And the idea is basically, build a really good foundation model, just kind of like what everyone's doing, and then partner with a lot of other organizations who have data, who have expertise, who have some problem that they're trying to solve in the real world. So a lot of things like agriculture, trying to understand what crops are growing, how well they're doing, wildfire risk, trying to model, what forests are in danger, where sort of resources could be allocated. And then a lot of like smaller projects like mapping all of the ecosystems of the world or mapping where all of the mangroves are and how the mangrove forests are doing, things like that. So foundation model at the core of everything, and then on top of that, all of these sort of partners that we have that we're working with to try to solve some of the problems that they care about.
Right, amazing. So develop the foundational model and then utilize it in all these different areas that you're working in. You mentioned there's an awful lot happening with foundational models. How does Olmo position itself? Does it position itself to do something different from what others are doing, or is it taking a different approach?
Well, yeah, we're trying to be the best, I guess. I think one of, AI2 has a number of strengths, but one of the things that has been really nice about AI2 is just the resources that we have there. They've really devoted a lot into this project in particular, and this is something that is a challenge, obviously, in AI research these days. You need GPUs to be able to do this kind of foundation model research, and we've been fortunate to have access to pretty good compute clusters. So we've been able to run a lot of experiments and try a lot of different things. I tend to think of research, honestly, as like throwing a lot of stuff at the wall and seeing what sticks and kind of getting lucky sometimes, and then putting a lot of that stuff together and building something really good out of all of these sort of random trials of stuff. So in some sense, we've been fortunate in that we have a lot of ability to try a lot of different stuff. And I think that's something that isn't super common, especially in kind of the academic research world. And especially, if we think about like what our partner organizations were doing before we started working with them, they definitely didn't have that kind of resource. We also just have a bunch of really talented people who have a lot of experience doing, computer vision, geospatial research work. So we are, I would say, currently positioned in the sort of free satellite, lower resolution domain, in that we mostly work with Sentinel-1, Sentinel-2, and Landsat data. So these are all satellites that have basically free data available that you can download. Anyone can download. I think Sentinel-1 and Sentinel-2 are from ESA, and Landsat, I think Landsat's from NASA. You probably know this, right?
Yeah, thanks.
Yeah.
Yeah.
um, so we're focused more on the lower resolution satellites. That's what we sort of pre-trained the foundation model on. And I would say, other than that, we're really trying to focus on any tasks that our partners have indicated are important to them. So we do a lot of work in terms of like agricultural type stuff, a lot of land cover type stuff, um, forest sort of problems, things like that. But we really want to build something that's pretty general purpose. The other thing I will say is that there has been a lot of focus in the community on embeddings. And we tend to think of ourselves as pushing in the other direction, which is towards training and fine-tuning models for specific problems. So instead of focused on getting good results out of embeddings, we're focused on building a model that we can bring in our partners' data and fine-tune for their specific problem. Because we've just found that, embeddings only get you so far. And if you can fine-tune the full pipeline on a particular task, you can get really good results. Even if they don't have that much data, as long as you have a good pre-trained model, you can usually get better results fine-tuning than you can get out of the embeddings. Which isn't to say, we don't want people using embeddings. We will produce embeddings for you. We have tutorials on how to get embeddings out of OlmoEarth. So, I think embeddings provide a really good tool for fast iteration and for quickly kind of getting results. But if you really want sort of the next level in terms of performance, I think fine-tuning is sort of the way to go.
Mhm. Thanks for clarifying that. And also, it's good to understand, where you think embeddings are positioned versus fine tuning. Um, I guess one of the areas people might utilize embeddings is in sort of traditional workflows, or when they want to join with other kinds of data sources. The other approach, which I think you guys have taken, is to actually include those data sources in the training. So you have maps that are used in the pre-training, etc. Do you mind talking a bit more about that?
Yeah, our pre-training sort of came from, again, this sort of long iterative process, I would say. But uh, Gabby is on the team who worked on a couple different foundation models before this, but Galileo in particular, right before OlmoEarth. So we started with basically this idea of building on top of Galileo. And we tried to re-implement Galileo ourselves and basically failed. um, so what happened was uh, we were trying to Galileo is a latent masked image model, foundation model, which means that you're trying to do reconstruction, but you're trying to do like masked image reconstruction. You're trying to do it in latent space. So you convert the image into tokens, and then you mask out some of the tokens and you reconstruct them. But the target encoder, so the thing that you're trying to reproduce, is a standard like sort of target encoder in a similar way to like how Dino v3 or something works, in that it gets updated during training too. So with latent masked image modeling, latent MIM, the target encoder gets updated via basically this rolling average of your encoder for the full training process. So you have your encoder, your decoder, and then your target encoder. And your target encoder is this rolling average of your encoder from the sort of full model. And what the rolling average is supposed to do is stabilize the model enough that you're not trying to target kind of this moving target um, in this reconstruction process. But what we basically found was we couldn't get this to train well. The model always basically figured out ways to cheat and kind of diverge. And what that means is basically um, we're trying to reconstruct these tokens, but the target encoder can produce sort of trivially easy solutions for the encoder to reconstruct. And then the problem doesn't get interesting. It sort of collapses, and you don't learn good representations. You basically just learn to produce some sort of basically positional encoding type thing or something along those lines. There are various ways in which the model can sort of diverge. So basically, we tried to reproduce Galileo. We failed. We went back to the drawing board and we were like, why is this collapsing all the time? We narrowed it down to our target encoder and sort of this moving target that we were trying to reconstruct. And that was too difficult of a process, we decided. So we froze the target encoder. And we used a very shallow target encoder. We actually just take our image and we project it through one random projection to get it into token space. And then we're trying to reconstruct that. So we're not reconstructing in pixel space because, we found basically you can reconstruct in pixel space. It tends to produce not quite as good of reconstruction. So we're reconstructing a token space and we're using this contrastive loss. So sort of a class-based loss in some sense, or, you have a softmax over the match between the tokens that you're trying to match together and the tokens that you want to be different. And you're trying to optimize for that. But we found basically that this frozen target encoder that was just these random projections into token space worked pretty well, and it stabilized our training a lot and enabled us to do a lot more sort of experimentation without worrying about collapsing all the time. And this is something that Gabby said too in developing Galileo. They saw that I think he was saying like 1 out of every 4 runs or something would collapse. And they had less of an issue with it, but it was something that we were seeing so often that we just had to kind of deal with. So then once we sort of dubbed this Latent MIM Light, I guess, because it's kind of this lighter weight version of latent masked image modeling. We're still doing masked image modeling in latent space, but the target encoder is not quite as interesting. And then we have a bunch of other sort of tricks and things that we worked out in terms of improving performance for the foundation model as well.
Mm. It's really interesting to hear you talk about kind of the details of the pre-training there. It sounds quite different from just sort of fine-tuning a regular model, right?
Yes,
It all
absolutely.
sounds probably even more of an art than that is.
Yeah, I would say, again, a lot of what we're doing is just kind of throwing stuff at the wall and seeing what works, but also pulling a lot from literature, seeing what people are doing. It is, it always strikes me. I come to satellite data from a computer vision background, and I think of everything as an image. And it's amazing how much satellite data is not an image at all. You can get uh, so many good results just from thinking about the time series aspect and ignoring all of the spatial data. You can just think, 1 pixel, look at how it evolves over time and get really good results that way. You have all of the multispectral information. So it's not just kind of the RGB. It's like, how does this spectral signature like change over time? And I think in some respects, especially with the data that we're dealing with, which is low resolution satellite data, the spatial component is almost the least important part in a lot of these tasks. I think the most important component is kind of the spectral information and this temporal information. So coming at it from a vision background, a lot of things are different when you start to think about satellite data. And this is an issue with pre-training, because we're doing reconstruction of our masked image, there's a lot of redundancy in the data. If you have Sentinel-1 and Sentinel-2 data, a lot of those patches are somewhat similar to each other, and it's fairly easy to do maybe some of that reconstruction. Or if you have multi-temporal data, if you have one timestamp and then another timestamp a month later, that reconstruction process can get a lot easier because you can just look backward a month, see what was going on, and then use that as a very strong prior. So a lot of the changes and adjustments that we did to our pre-training algorithm have to deal with the sort of unique challenges presented by satellite data as opposed to, say, images themselves. So that means, handling the fact that we have these different modalities that are very strongly correlated with each other, handling the different time steps that are also very strongly correlated with each other, and basically tweaking the reconstruction task in such a way to make it harder and more interesting such that we learn better features instead of just like kind of this trivial task.
Mhm. And there's other aspects to using these models, which I know can be challenging for people. For instance, like the preparation and normalization of the data
Oh my
itself. Is
gosh.
that an aspect that you can tell us a bit about?
Yeah, this is something that we run into all the time with other people's models, basically, mostly because we know how our model is supposed to be normalized and what data is supposed to go into it. But as part of writing the OlmoEarth paper, we did a very large evaluation task where we basically took a bunch of foundation models that were in the literature, all of the ones that we at the time sort of recognized as being pretty competitive with the state of the art, or just like historical models that people cared about. We took them all and ran them all on a standard set of evaluations. And as part of this, we had to basically take all of these external code bases and force them into our code base and get them to run on all of these evaluations. And everyone uses a different normalization. Are you normalizing by one standard deviation? Are you normalizing by two standard deviations? Are you zero centering, or are you, clamping between 0 and 1? Everyone does kind of different stuff with their input data. And so we had to try to very carefully go through and figure out, what these models were expecting. And we messed some of that up, and we'll be the first people to sort of correct our papers when we do get some of that stuff wrong. I think like tomorrow, a small archive update is happening because we got some of the Prithvi numbers a little bit wrong. It doesn't affect the overall story of the paper, but it sort of speaks to the how complicated it is to get all of these models to work. And then that's not even to say like, are you using Sentinel-2 data, raw? Are you using it with, what level of post-processing are you using it at? There's all of these kind of, and then everyone uses different normalization statistics too, right? So it's like, if you calculate statistics during pre-training, you have one set of statistics, but then if you run it on a data set and that data set is weird. So we saw this a lot with Mados, the evaluation task, which I think is like trash in the ocean,
Mm,
basically. But all of the input tiles of Mados are ocean tiles. And those have very different normalization statistics. So if you use the statistics from pre-training, you might get much worse results on Mados. But if you actually look at the statistics from just the Mados data set, you can renormalize the data using the data set statistics, and then you get different results. So it's just, yeah.
mm.
What our solution to this was, we just tried to sweep as much stuff as possible. So everything that we could think of to try different versions of, we would sweep. So for example, normalization statistics, how we were doing pooling across tokens, all of this kind of stuff. We tried to make sure that it didn't influence the results that these models were getting. But of course, if anyone out there sees their model in our paper and sees that it's getting worse results than they would have expected, and knows why, we would love to get emails, and we can make corrections to it. But we tried to have as fair of a comparison as possible, at least.
It's a really interesting nuance that you had to reprocess the data so it better match the sort of normalization statistics that your model was pre-trained on. And I guess kind of is maybe one example of some of the challenges people might face when using these models. Another point you brought up was about evaluation. Do you think that we're approaching some sort of standardization on how we evaluate foundational models?
I wish. It would be really nice if we were. Um, I think this is like an XKCD comic, right? It's like, oh, there are 14 different standards out there and no one can agree. So I'm gonna make, the new one, and then there are 15 different standards. I think we are doing the best that we can. And, one of the reasons we ran all of these evaluations ourselves was because there isn't a standard set of evaluations that everyone sort of agrees on as like the right evaluations. It also like it's sort of silly to think of this as one monolithic like domain, in that like we only care about low resolution satellite stuff, and a lot of like big evaluation frameworks will include like aerial imagery or high res imagery, and that's not something that we train on, and also not something that our partners really care about that much for the tasks that we're doing. But some other model, they might really care about high resolution data, they might not care about Sentinel-1 and Sentinel-2 at all. So depending on the domain, there's going to be different evaluations that you care about. We tried to basically span as much breadth as we could in terms of the different sorts of tasks and stuff in the evaluations that we were running. But yeah, it's a challenging thing. And I think basically the community is starting to slowly recognize that we probably need something. But I don't think, like in computer vision, it was easy. It was like, all right, ImageNet for classification, and maybe like, well, Pascal VOC, but it got too easy. But then we had Coco, and Coco was really good. So Coco for detection, and later on, those sort of saturated. So maybe we got some other things, but there's no, ImageNet for geospatial models yet. There's, GeoBench 2. These are, I think, pieces of the puzzle, maybe, but I don't think they are comprehensive. And I don't think any evaluation set can really be comprehensive, which is why we're just trying to work with partners and figure out what they want to do, and then try to get as good of results on their particular tasks as we can.
Mhm.
But yeah, it's a very hard problem. We've been thinking about this. We've been thinking about, can we release some sort of evaluation benchmark that would incorporate a bunch of tasks from our partners, because we have, sort of land cover, change detection, single pixel tasks, segmentation tasks, detection. We have a bunch of different, sort of stuff from different domains that I think would be a useful resource. I don't know if anything will ever be the one monolithic evaluation, but I think having a lot of different options out there is good.
Yeah, let's hope that we can kind of stimulate that conversation and help, move things forward. Because as you say, there's a lot of kind of complexity to it, and what are you even trying to compare a lot of the time, needs to be clarified. Another topic that's come up in, I guess, the conversation recently is this comparison of foundational models to kind of smaller and traditional models. And there's been a bit of kind of dialogue stating that actually foundational models are not always much better. And they give examples of training small models on data sets, and the small model achieves better performance. Could you maybe talk a bit about that topic?
Yeah, I guess this was something. I don't know if you were you at the iClear workshop on geospatial models? This was a topic that came up during the panel
Mm,
discussion there.
right.
Um, and there were some strong opinions at that workshop, I would say. I think we are, so for one thing, we are a very evaluation focused field, in some sense. So like if one thing works better than another thing, just use that thing, I guess. Like we're not saying everyone should use our foundation. Okay, everyone should use OlmoEarth for everything. We're not saying everyone should use foundation models for everything. If you have a small model that works well, by all means, like you should use it. I think like you should just try things and test out how well they work and use the best one for your particular use case. Um, we have found that for our partners, we've done a lot of this comparison. Our foundation model works in general better than the sort of bespoke solutions that they were using beforehand, which are usually something like random forests or gradient boosted decision trees or something on top of some sort of extracted features, which are very powerful models. But we can basically get a lot of benefit out of pre-training. We have these strong features that we've pre-trained, and then the benefit of foundation models is you don't need as much labeled data during fine tuning. I think if you have a ton of labeled data, then you could train any particular model. It wouldn't really matter if it was a big model or a small model or whatever. And in general, most people don't have a lot of labeled data. It's very time intensive to label data for these kinds of tasks, especially like some of the agriculture tasks. People are like going on the ground, looking at what crops are growing, tagging them, geolocating it. Like it can be require sort of real world interventions to do some of this data labeling. So uh, yeah, if you find that for your task a small model works better than a large foundation model, use the small model. And we have a lot of people where the foundation models work better, so we're going to keep helping them use it. But you know, we're not trying to say that everyone should use this one thing for every single thing. And there are other considerations too. Like Skylight, I think still uses a convolutional network based approach because they need a little bit more efficiency than our current models can kind of produce. So there are definitely like efficiency trade-offs for some things. There are a lot of different trade-offs to
Mhm.
sort of consider for sure.
Yeah. Thanks for clarifying your thoughts on that. I think it's probably needs to be included in the evaluations in some way, but I guess that's part of an ongoing conversation there. I just want to sort of circle back to Olmo and talk a bit about the sort of usability and the sort of practical and ergonomics of it. You mentioned that many of the people, they've kind of got existing approaches, maybe using kind of traditional models. How are you sort of onboarding them to a foundational model? What's your approach there?
Yeah, well, this is again one of the great things about working at AI2 is just they're willing to dump a lot of resources into building out infrastructure around this kind of project as a whole, which means we're not just building the foundation model, but the OlmoEarth platform is this whole platform for using these models as well. So it includes things like labeling data, going in and actually like either doing segmentation or detection or point labels or whatever you want to do, finding a bunch of like tiles and look, you can sort of use the interface to scroll through them over time, see how things are changing. So you can label data in the platform, and then you can just import data if you already have it. A lot of our partners already have data. You can validate existing data. There's whole workflows for like assigning it to people and making sure that everything makes sense. And then actually taking the foundation models that we've pre-trained and then fine tuning it on data that's in the platform. And these are mostly with like little wizards, basically, where you're selecting like what kind of task do you have? What does your data look like? Things like that. So trying to make it as straightforward as possible to get people started, all within basically this web platform where people can bring their data or label data, um, pre-train or fine-tune models, and then also run the models. So perform inference as well. So they can basically select areas to run inference and time ranges to run inference over. And it'll take their fine-tuned model and run it on these windows and generate geotiffs as results. Basically, you can view the results, or a lot of people just want to download the results and use them in their own workflows. So we're trying to build out basically this platform where people can do their full, sort of workflow of geospatial stuff, or at least part of their workflow. Again, a lot of people, that you generate a map, but that's not the end, right? That's kind of where we stop. But then people have to take that map and do something with it. So trying to
Mhm.
make that available so people can download it and use it for whatever kind of the rest of their workflow is. So we're trying to do that as one piece of the puzzle in terms of like connecting with people who don't have any experience with machine learning, who just want to like input their data and get results out of it. And then on the other side, we have everything is on GitHub. You can look through all of the source code. A lot of it is open source in terms of sort of freely usable, available, so people can download the modeling code. They can run the models themselves. They can fine tune the models themselves, and we try to provide a lot of like tutorials and resources for people who want to dive a little bit deeper into the code base and actually use the foundation models in kind of the native PyTorch implementations.
Right. So full spectrum there, web user interface or people that don't want to code all the way through to here's the code and the weights and off you go and modify it, etc.
Yeah,
Very
and this does mean
ambitious.
we've limited somewhat the number of people who are using the platform currently, and that we only have bandwidth to onboard a few organizations at a time, basically. So we're working up more and more organizations, getting them in the system. But like if you signed up, today, it might be a little while until you heard back from someone in terms of
Mm,
getting access to the platform. And then, but with a lot of partners, we're working one-on-one with them to get them into the platform, to get their data in, et cetera, and make sure they have a
mm,
good experience. So we're really trying to have a really good experience for the partners that are working with us, and slowly expanding that over time.
mm. Yeah. So there's a couple of other platforms, obviously Google Earth Engine and Planetary Computer. It sounds like this is going to be something a bit different though.
Yeah, I would say, I mean, obviously, like Google Earth Engine is this kind of behemoth, and they have a lot of resources available. I think they are going to add in fine tuning for their foundation model at some point, maybe, but it seems like you maybe will need to pay for it. You don't have to pay for it if you use our platform, and you can download the model. It's not some black box sitting somewhere in the cloud. So, uh, and again, we're being sort of picky in terms of the organizations we're working with. We're trying to find organizations that we generally support the mission of, but that means that we are providing all of the compute for free. The platform is free, et cetera. So really trying to support the missions of these nonprofits, NGOs, some governments. I think like the Kenyan government we're working with to do crop modeling, mapping kind of stuff.
Mhm.
So yeah.
So it's pretty much kind of a review process to get access to the platform at the moment, and the scope might evolve
Yep.
over time.
Yeah.
Fantastic. So we can direct people to the OlmoEarth platform website. Is that what it's called?
Yep, OlmoeEarth platform. If you just, I think it's allenai.org/OlmoeEarth, will get you there. Or just search OlmoeEarth.
Mhm.
We have pretty good SEO, so it's
Fantastic.
sort of a
Um,
strange name.
yeah, I'll put the link in the show notes. Just to finish up, I know you had a point one release, and I think you're working on a point two release. Do you mind just talking about what's been happening very recently?
Yeah, we had 1.1 come out, I think last week, maybe 2 weeks ago. And then, yeah, we have version 1.2 happening. 1.1, we just got significantly faster. We're using like 30% of the tokens that we were originally using. So the model got a lot faster in terms of pre-training and fine-tuning, and inference time. And version 1.2, we had a lot of people coming to us because a lot of people still want to use embeddings. A lot of people came to us and said our embeddings looked weird, because they did look weird, because we were using sort of standard 2D Syncos positional embeddings for positional embedding in the image. And when you run like PCA on the tokens that we were producing, a really clear signal was this positional embedding that we were adding in. So it produced these really stark artifacts in our embeddings. And even though the embeddings worked well, people don't trust something that has that strong of a visual artifact in it, I would say.
Yeah.
So we're using rotary positional encodings now, rope and that basically got rid of this really strong artifact that we were seeing previously. We get better results too on many evaluations. Again, it's tough, right? Like you go up on one evaluation and then you go down a little bit on another evaluation. It's like, well, how much do I weight pastis versus Eurosat versus Matos versus, there's just SO2 sats, like so many different evaluations. And that was one of the beautiful things about computer vision is if you got better on ImageNet, you got better across the board on basically everything. And in geospatial stuff, that's not the case. If you get better on one task, it often means you're getting worse on other tasks. So we got better on a lot of stuff by adding rope in, and that's version 1.2. That will be out shortly, I think. Probably, I don't know how long it takes to upload the episodes to YouTube, but I would say within the week, we will have 1.2
Fantastic.
available.
Right, exciting. So people will see, I guess, is there a paper there or is that just like a kind of
There'll be a
code
tech
update?
report. Yeah,
Paper report, yeah.
we'll upload a tech report, but it's just like we added rope, and here are the
Yeah,
experiments that we did. It's not a very impactful tech report, I would say, but
amazing.
interesting maybe.
Well, thank you for joining me today. It's been a really interesting conversation. I'll drop the links to the platform in the show notes. And in terms of following updates from the team, I guess LinkedIn or your own blog, probably the best places.
Yeah, we actually were just talking about how we don't have a LinkedIn, but we maybe are going to make one.
Okay,
Yeah, I you got me on the spot. We'll probably have an OLMo-Earth LinkedIn at some point. The OLMo-Earth website is a good place for updates, and if you're interested in the platform, there's an email to send an email to on that platform website. So yeah, a few options, but stay tuned for hopefully some sort of more permanent blog or LinkedIn as well.
fantastic. All right. Well, looking forward to all these updates. Once again, thanks for joining me and see you later.
Yeah, thanks.